All right, Precalc, we are on lesson 6.3 and we're going to start talking about vectors. Vectors are interesting. You probably did them, maybe you did them in physics already. Vectors in the plane. Our essential question is, can you represent vectors as directed line segments? Can you write the component forms of vectors? So half the battle here is going to be vocab. So I'm going to give you little funny hints to remember. If you would like to look on page 424 of your book, please open up your book and look at what vectors are. What we need to remember are vectors are lines, and they go from initial and they go to terminal. Initial to terminal. We're going to start with number one. Number one states, let U be represented by the directed line segment from P, 0, 0 to Q, 3, 1. And let V be represented by the directed line segment from R, 2, 2 to S, 5, 3. And we want to show that these two are equivalent. We want to show that U is equal to V. So the first thing that we have to do is we have to go ahead and show PQ. The way they write vectors is they write PQ like this. And really, all we're using is that good old distance formula from Algebra 1. So we are going to take 3 minus 0 quantity squared and add it to 1 minus 0 quantity squared. And it looks like we get 9 plus 1. So it looks like the distance from initial to terminal of PQ, or the vector, is 10. So I also have to look at RS. RS, we're going to take one of the points, 5 minus the x on the other point, 2, square it, add it to the y in the first point, 3, minus the y in the second point, square it. And this is going to also be 9 plus 1, which is 10. So all they wanted us to do is to prove that PQ was equivalent to the vector RS. We did that. Example 1 is done. So U is equal to V. All right, the next question says find the component form and the magnitude. So component form and magnitude are going to be very similar, but component form, we write component form in what I call these little carets. So component form is going to be written like that, where the magnitude is, we could use the component form and find the magnitude. What we found above was the magnitude. So let's start with the component form first. The component form, we're literally just taking, all right, so we're just going to take the terminal and subtract the initial. -7 minus a -2 gives us a -5. And we're going to do the same with the y's. The terminal minus the initial. 9 minus 3, that gives us 6. Now, the confusing thing is, because we're going to start getting to a lot of different forms, the component form we write in these little carets. So the component form of this will be -5 and 6. Yes, that does look like an XY point, but component form, I say, is written in carets. Component form, carets. Now, the beautiful thing about component form is I can take this and straight from here, I can do the magnitude. Because remember, we just subtracted these, which is what we do for the magnitude, like we did in example 1, which is the distance formula. So again, this is just that distance formula from good old Algebra 1. And we are going to go ahead. Now remember, I could do the same thing, -7 minus a -2 and square it, and 9 minus 3 and square it. But notice I get the exact same thing here, -5 squared and 6 squared. So really, I can just take these two numbers underneath the radical and square them, and I find out that the magnitude of this is the square root of 61. So they typically show magnitude like that, like I wrote it in those double letters, so just get used to seeing that. And we're going to end today with vector operations because this is quite simple. This is very similar to what you've seen in the past with just adding like terms. So they're using vector addition and scalar multiplication. So if u is the component form u sub 1, u sub 2, and v is v sub 1, v sub 2, and they're asking us to add u plus v, I'm just adding the first and the second. Scalar multiplication is just like you would think it is. You are taking k times u, you're just multiplying k into u sub 1 and u sub 2. So let's go ahead and take a look at example 3. The first thing is saying, let's add u plus v. If I was to add the u's, 3 plus 1 gives me 4. 2 plus 1 gives me 3. Next question tells us to subtract them. If I am to subtract, 1 minus 3 is negative 2. 2 minus 1 is 1. For the next one, they're telling us to go ahead and multiply the u by 2. So I'm going to double the u, 2, 4. And then I'm going to subtract 3 times the v, 9, 3. And when I do that, it looks like I get negative 7, 1.